Let's see touching circles and theorem of touching circles. Touching circles. If two coplanar circles have one and only one point in common are called touching circles. And their common point is called point of contact. Okay. Example in figure. Here you may note circles with centers O and P touch each other at point T. Okay, it is a case of externally touching circles, and here is a case of internally touching circles. Circles with centers O and P touch each other at point T. Okay. In figure, circles with centers O and P touch each other at point T. Okay. In figure 1, circles with centers O and P touch each other externally, and in figure 2, circles with centers O and P touch each other externally. Okay. Now here in this case you may note, if circles touch each other externally, then center of those circles lie on opposite side of a common tangent. Let us suppose line here is their common tangent at their common point of contact T. Okay, line here is a common tangent. Here, in a case of externally touching circles, externally touching circles, centers of those circles lies on opposite side of their common tangent. at common point of contact. Similarly, in a case of internally touching circles, centers of those circles lies on same side of their common tangent, but that common tangent should be at common point of contact. Okay, at the common point of contact. Now let's see theorem of touching circles. Prove that if two circles touch each other, then their common point lies on a line joining their centers. Okay, as per this statement, first of all, let's draw a situational diagram. Situation is about two circles which touch each other. Okay, we know that by definition, coplanar circles having one and only one point in common are called as touching circles. Okay, therefore there are two possible cases. One is a case of externally touching circles, while other is a case of internally touching circles. Let us suppose that centers of those circles be O and P. Okay, circles with centers O and P touch each other at point T. Okay, then it is a point T. Now we are interested to prove that this T lies on line OP. Okay, T lies on a line OP. Yes, you may see here, if we draw a line OP, T lies on line OP. Here also in this case, you may note T lies on line OP, but theoretically we are interested to prove this thing. Okay, first of all, let's mention given to prove. Given circles with centers O and P touch each other at point T, and to prove T lies on line OP. Okay, now information is insufficient, that's why let's do a construction. construction. Draw a common tangent L at point of contact T. Okay, at the point of contact T. Now if we draw such a line L which is tangent at point of contact T, means it is common tangent to both these circles with centers O and P. Okay, line L is their common tangent. Let's mention a proof. Okay, here seg OT is a radius, line L is a tangent, means seg OT perpendicular to line L. Similarly, seg PT is perpendicular to line L at point T. In this case also, seg OT is perpendicular to line L as well as seg PT is perpendicular to line L. Let's mention here seg OT perpendicular to line L, seg PT is also perpendicular to line L, and reason for this, since tangent theorem. According to tangent theorem, we learned that a tangent is perpendicular to the radius at the point of contact. Okay, and therefore seg OT and seg PT are perpendicular to line L at same point T, since to any line at a point we can draw one and only one perpendicular. Okay, one and only one perpendicular, and therefore line OT and line PT are not different lines, means these must be one and the same. Okay, and therefore line OT and line PT must not different, that is, they must same. Okay, line PT and line OT must be same, and therefore O, P, T are collinear, and therefore what? Therefore T lies on line OP. Therefore T lies on line OP is proved. Okay. Now remember this. Number one, if circles touch each other, then their common point lies on line joining their centers. Okay. If we consider a case of externally touching circles with centers O and P which touch each other at point T, we may note T lies on line OP. Similarly, in a case of internally touching circles, you may note T lies on line, T lies on a line OP. Okay, T lies on a line OP. Now here, you may note, in a case of externally touching circles with centers O and P having common point of contact T, here you may note O dash T dash P. Means if R1 and R2 are radii of these two circles, then distance between centers of these circles will be sum of their radii. Means in a case of externally touching circles, distance between centers of such circles is equal sum of their radii. And in a case of internally touching circles, if R1 and R2 are radii, then here you may note O dash P dash T means OP equals OT minus PT, means OP equals R1 minus R2. Means if two circles touch each other internally, then distance between their centers is equals difference between their radii. Let's mention here second and third point. Distance between centers of externally touching circles, is equal to sum of their radii. And number 3, distance between centers of internally touching circles is equal to difference of their radii. Okay, thank you.